Ladies and gentlemen, please welcome Technical Fellow Microsoft Corporation, Mark Russinovich.
Good afternoon, everybody. There we go. How's it going? Good start to the conference so far? All right. Well, welcome to Windows Azure Infrastructure as a Service, Windows Azure Virtual Machines and Virtual Networking. I'm Mark Russinovich, and for the next hour and 15 minutes, I'm going to take you on a tour of the capabilities and features that we released about 2 weeks ago. Now, how many people are just out of curiosity are already playing with these virtual machines? Anybody? So just, yeah, a few people. That's great to see. Those of you that are looking at this and maybe have followed Azure from the start are saying, what are you guys doing with infrastructure as a service? Have you given up? Did you punt? Did you say this platform as a service thing isn't working out? Well, actually, it does make sense in the context of where Windows Azure has been and where we're going. And I'll explain now how we see infrastructure as a service fitting with platform as a service. The way that we view it is starting with the pure Windows Azure platform as a service vision, which started out back in 2007. We wanted to create this great new world where you could just focus on your application and the infrastructure would handle the rest. Now, what we found as people started to adopt the platform, first internally and then as we opened it up through the PDC to external people, is that they would want to bring existing chunks of code onto Windows Azure. And if you look at the first platform as a service environment we had, it was pure partial trust.NET, ASP.NET for the front ends and .NET for the worker roles. And there's lots of code that's not compatible with that environment. If you've got native code, if you've got code that requires admin rights, if you've got code that requires some setup program to run before when the virtual machine gets provisioned, all of that wasn't possible in that world. And so we wanted to make it possible for people to bring their existing code, and you can see that over time we started to create these on-ramps for existing code, including things like the admin mode that came along. Even virtual machine role was something that we consider an on-ramp, and I'll talk about how the existing virtual machine role fits with this new virtual machine capability that we just introduced. But the fundamental on-ramp is really just letting you take wholesale a server application, one written for the server environment, and put it up in Windows Azure. And there's a fundamental difference between Windows Azure's platform as a service philosophy and the philosophy that Windows Server applications are traditionally written to. And that is that in Windows Azure, you get the stateless model, which gives you these nice capability to scale out and high availability just by creating clones of a machine. And because it's stateless, none of them have any kind of unique intrinsic personality. It doesn't matter if they die on a server. You just reincarnate them on a different machine. They don't remember anything about their past. They just get a brand new, fresh image. But with server applications, those are stateful applications for the most part. When you have a SQL Server database in it and the application writes something to the database, you expect that even if the server fails and you start the application again on a fresh server or you reboot the machine, that the contexts of the database are still there, that the data is not lost. Same thing if you go and modify the configuration. You RDP in and you make some tweaks in the registry to optimize performance. You apply patches. You expect all that stuff to persist. And so that was the fundamental on-ramp, really, to open the door to the vast swath of existing server applications and make it possible for you to bring them up into Windows Azure. Now, our goals when we set out on this journey to create this major on-ramp, we started about a year ago. We said, let's make this final on-ramp into the cloud. And we had a number of goals that we set in mind. First of all, we wanted to make it easy for IT pros. So you don't need to be a developer to actually bring your applications up into Windows Azure. That was one goal. We wanted to support key server applications. So you can imagine which server application we said we've got to be great for this server application. It's the one that everybody runs as part of their larger server applications no matter what, and that is not Exchange. Not SharePoint. SharePoint depends on this, though. not SQL. There, I heard somebody say it. SQL Server. We wanted to be great for SQL Server, but there's some other key server applications you saw me demo in the keynote, Active Directory and SharePoint, that we also put on the list. But SQL Server was really a fundamental one because we wanted to make sure we got great performance on SQL Server, and I'll talk about some of the ways we did that. We wanted easy storage availability. Now, if you take a look at the other cloud provider, you can probably guess which one I'm talking about, the public cloud provider. They've got kind of a Roach Motel model with their VM-backed storage. Once you check it in, it's very hard to get it out. And we wanted to take a different approach. We wanted to be open so that when you put your VMs in Windows Azure, you saw me in the demo, in the keynote, that these things are just standard Windows Azure blobs that you can use, copy in and out using standard Windows Azure storage APIs or storage tooling. That was one of our key goals as well. We wanted high availability features so that we wanted you to be able to create those SharePoint farms with scale out and availability such that if a server failed in the data center, the application would continue to operate. Advanced networking, of course. I'll talk about some of the advanced networking features. You saw me show the hybrid connectivity back to on-premise. That was a key feature in this release, the virtual network gateway. And then finally, and this is, again, goes towards the message about it being an on-ramp, is that we didn't want to create two side-by-side siloed worlds, one with platform as a service and web and worker role, and then the other one sitting over here separately, infrastructure as a service. We really wanted to create a world where there's a continuum. And I'll talk later in this session, about how we see applications that migrate from pure infrastructure as a service to more over time platform as a service. And that's possible because we build them both in the same foundation. And so all the key concepts apply to both of them, and you can integrate them tightly together. One of the key mantras we had, actually, and this was one for the development team, was that we can't, if it requires a developer, that it's not infrastructure as a service. In other words, we've got to take these existing server apps without change and make them run well in Windows Azure. We can't go to the Active Directory team and say, change Active Directory so that it works in Windows Azure, even though one of the developers tried to do that at some point. That didn't work. The Active Directory team said, sorry, we're shipping lots of versions or copies of Active Directory. We can't change it for you guys. You just need to make it work. And so this slogan came in handy for us to be in the right mindset about what we were setting out to accomplish. How many people remember when we announced virtual machine role at the PDC a couple years ago? Does anybody? Some people remember. A lot of people, you might have remembered at one point and then quickly forgotten about it because you said, hey, it's virtual machines, it's infrastructure as a service. In fact, in the keynote demos at the PDC, we kind of said that it was infrastructure as a service. And this is kind of marketing getting a little ahead of things because it's not. Really, virtual machine role that we introduced back then was one of these on-ramps. And the on-ramp was specifically for applications that have a very long setup process. What virtual machine role let you do is fit into the stateless model of Windows Azure, but give us a baked image with the program already pre-set up and pre-configured in it. And that means that you could give it to us, we could stamp out clones of it, and every clone that got stamped out doesn't have to pay that price of running the setup program and configuration. So if it was something that you couldn't really easily script, it was a very manual process to install the software inside the virtual machine, that VM role could work for you. Or if it was a very long setup process, if it took 10 minutes to install the software that you wanted in your worker role, for example, then virtual machine role would work. But the fundamental difference between what we delivered 2 weeks ago and the original virtual machine role is that persistent operating system disk. Virtual machine role, same stateless model. You can kill them, they clones, they get reincarnated. But with persistent VM roles, and that was the internal name we used actually, persistent VM role versus stateless VM role. And then the marketing term came along and called it virtual machines. But that's the fundamental difference between the two. If you look at what platforms we've got available at this launch, we have, of course, Server 2008 R2. We've got Server 2008 R2 with SQL Express in it. And we've got Server 2012 release candidate or release preview right now. And you can also see that we've got various Linux versions. This list is subject to change. And that lets me highlight the fact that this is actually a preview release that we just launched. So it's kind of V0.9. A bunch of the features are there fully fleshed out, but we're continuing to make improvements, finish some of the features out. and at some point we'll go to general availability, where we open it up broadly. Today with this preview, you got to go apply for virtual machines, and everybody that's applying we're giving accounts to, but before we just open it up so that anybody can get it, we want to make sure that everything's working great. But we also, out the door, have these platform images, and as we continue to move forward, we'll add new platform images as well. So you'll see various server applications being bundled into platform images. You'll also probably see additional Linux distros come on board as well. I mentioned that in the keynote that we're back in these VMs with Windows Azure storage blobs. And this also was a point which kind of feels obvious to us in retrospect, but a year ago when we started out on this path to create these things, we were faced with the question of where do we store the VMs, these persistent VMs? What's the backing durable store? And again, if you look at what Amazon does, they created this separate SAN-based solution called Elastic Block Store for their VM images, and they've got something separate. They've got AWS S3 storage for their platform as a service storage solution. We've got Windows Azure Storage, and we said, do we need to create a SAN-based solution specially for VHDs, or can we leverage what we've got? There's lots of benefits we saw to leveraging Windows Azure Storage instead of creating a separate SAN-based solution, like the fact that all of the APIs work. Also the fact that we're continuously driving massive improvements into the scale and performance of Windows Azure Storage. So we get for free, just by leveraging it, the triple replication we've got in the data center for a blob. When you create a blob in Windows Azure Storage, underneath the hood, the blob is copied, logically copied, not physically copied, to 3 different servers. We use erasure coding so that it's actually not making 3 separate physical copies. Just like parity, you don't have to create a whole copy to be able to tolerate a failure of any single server. But logically, it's like having 3 replicas. So if a server fails, we still have 2 more copies of it. We also automatically got the asynchronous replication across data centers. So all of this we just got for free, and that made us feel really good about taking the bet, because we also ended up improving Windows Azure Storage. Performance-wise, the characteristics of a VM hitting a blob are slightly different than what we saw with PaaS applications hitting blobs, and we optimize Windows Azure Storage now for this new solution. One of the things I want to explain now with respect to the way that VMs relate to Windows Azure Storage blobs is that to have a VM use a blob, you either need to make the blob into a disk or an image. And I'm going to explain now the difference between a disk and an image. So a disk, well, actually, let me start with an image. If you looked at the Create VM wizard that I showed in the keynote, you saw those platforms, those are actually called images. And what those are generalized VHDs. So they've been sysprep generalized, and that means you can make clones of them. Now, once you've instantiated one of those, the instance of it is called a disk. So you take an image, you make an instance of actual VM from it, and now you've got a disk. So the disk is kind of like bound to a virtual machine. And that shows up in your disk library in the portal. So that, and through storage APIs, through the APIs we've released, it's possible for you to take an arbitrary off-the-shelf blob and then import that into your disk library and then create a virtual machine off it. So the example, for example, where you have a VHD on-premise, you upload it into Windows Azure Storage as a blob, you can take that blob, make it a disk, and now create a VM from it, like I was showing you this morning. A number of disks is a question that we get, is how many disks can I add? How much storage can I add to these virtual machines? And the answer depends on the VM size that you pick for your virtual machine. You can see, just like most of the characteristics of our VMs, when you go from the extra small up to the extra large, you get better network performance, you get more RAM, you get more CPUs, and you also get the ability to attach more data disks to your VMs. If you look inside of a VM, there's the OS disk, there's a temporary disk, which is scratched storage that's local on the server. This is where the paging file goes. And if the server dies and the machine gets recreated, or that virtual machine gets recreated on a different server, you lose the paging file, which you didn't need really anyway. And then finally, you can add additional data disks to the virtual machine. On an extra large machine, you can add 16. And the size of a data disk, the maximum size, happens to match the maximum size of a Windows Azure page blob, which is 1 terabyte. So 16 data disks, 16 terabytes is the size of the additional data disk storage you can add to your virtual machines. Now, with respect to caching, so people say, what happens to the data but my VM writes to its disks? Where does it go? There's two answers by default, depending on whether you're talking about data that's going to the OS disk or data that's going to the data disk. Data that goes to the OS disk by default is cached locally on the server, and it's right back written to Windows Azure Blob Storage. Now, for the durability of the VM, we have to honor what the VM tells the storage subsystem to do with a disk write. Some of the writes that a VM makes to its disk are cached writes, but other writes are either flush writes, where it says flush all the cached data, or write this directly back through to disk. So SQL Server, for example, does a bunch of write-through writes. And so those, when they come out of the VM, even if they're on the OS disk, go and hit directly Windows Azure Blob Storage. We also cache the data locally on the server. And that means that if somebody then read that data, they're going to get it locally instead of having to go all the way to Windows Azure Blob Storage to get it. You'll see that the default policy for data disk, though, is different. It's no caching. So when you do a write, it always goes to the back end, whether the write-through flag is on it or not. Similarly, when you do a read, because there's no local cache, you're always going to be getting it back from blob storage. And the reason we chose the different caching policies is based on the kind of usage patterns we see for storage with respect to OS disks and then what people do with separate data disks. With the OS, the working sets, the amount of data being read and written is generally relatively small and will mostly fit in a local cache on the server. So it's actually performance efficient to cache the data locally. If you look at what people do with data disks, they traditionally create a data disk to put a SQL Server database on it. And the SQL Server databases then have a different kind of access pattern and are generally too large to fit in a local cache that we've got on the local server. So for those, we saw in our performance testing that we get much better performance with SQL workloads by not caching and going directly back and forth to Windows Azure Storage. The latency guidelines that we set for ourselves, we worked closely with the SQL Server team, and also the number of IOs per second, we worked closely with the SQL Server team. And I don't have numbers that I can share with you right now. In fact, you can go test yourself what kind of IOs per second you get on various workloads and the latencies you get on various workloads. But I will say that in cooperation with the SQL Server team, we wanted to target what they classified as Tier 3 and Tier 2 workloads, where Tier 1 is the super mission critical, buy the monstrous 1 terabyte SQL Server machine. We're in the midway to the upper end of Tier 2 workloads in terms of the IOs per second and the latencies that SQL Server defines as being in that range for SQL applications. And this is only going to get better. Like I said, we made performance optimizations to Windows Azure Storage to make it work great with VMs. And we're continuing to we've got a whole bunch of performance improvements that are coming actually in the next 2 to 3 months in 2 big waves that will improve things even further. So that's where we are in performance right now. And as a preview release, I think we're coming strong out of the gate. So let's take a look now at some of the things that I've just talked about with a demo. So let's switch over to the demo machine. And here I've got in the portal, I've got various virtual machines that I'm going to be showing you. And the one I'm going to focus on right now is this one right here. It's Serve 2012 16 terabyte. Now, let's call it 16 terabyte because we're going to add 16 data disks to it. Right now, it's got an OS disk, and it's only got 15 data disks for a total of 16 disks. So the way that we can add another disk to it, and before I do that, why don't we remote into this thing so we can see the data disk getting added to it. So here I've got Disk Manager, and you can see that all of these data disks sitting in here. But I'm going to go into the portal and say, attach. And if I'd had other disks that weren't already attached to VMs, it would have offered me the choice to add one of those disks to it. I don't have any unattached disks, so my option here is to create one. And how many gigabytes is a terabyte? I thought it was 1024, but the portal tells me it's 1023. So we'll go with that. And if I go back to this, in a few seconds, that disk is going to pop up and it's going to ask me if I want to go ahead and create a partition table on it. So let's wait a second here. And once that comes up, what I'm going to do is stripe all 16 disks using striping inside of Windows. When it comes to performance, let me talk for a second here about getting the maximum performance out of your virtual machine disks. First of all, obviously for SQL kind of workloads, you want to go with a data disk with no caching policy turned on. But second, kind of interestingly, Windows Azure Storage learns from your usage pattern. So if you're going to go do some kind of benchmark or look at what kind of performance you get on your applications, what I recommend you do is warm up the application for at least 45 minutes. It's over that time that what Windows Azure Storage does is looks for hotspots and will split hotspots across the table servers on the back end of Windows Azure Storage. So instead of hitting one spindle, you'll start to spread across spindles. And that's also something we can't get on the... I saw something flash. There it is. That's also something that you can't get on the local server. On the local server, we're spindle limited. With Windows Azure Storage, with its massive thousands of servers in storage clusters, we can really, with dozens of spindles on each server, we can take a single blob and spread it across lots of spindles to get great IOPS. And so that's a little performance tip. So I'm going to let that be regular MBR. And now what I can do is say I want a new stripe volume. Select all of these. And sure, drive letter F sounds good. Do a quick format. And this is going to convert them to a dynamic disk from a basic disk partitioning scheme. So this will take a couple minutes, and when it's done, I'll have one massive 16 terabyte volume attached to this VM, which allows me to create a fairly good size SQL Server database spread across not only blobs, but each blob then, depending on how they're hit, spread across spindles in Windows Azure Storage. So we're not going to bother waiting for that to take place. Let's switch back to the slides. Oh, actually, let's switch back, because I wanted to actually show you a couple of other things. Let's switch back to the demo machine. So you can see the disks here. I'm going to open this Storage Explorer tool, but that's not the Storage Explorer tool. It's right here. And if I go into the storage account here, you can see big storage. There are those VHDs right here. Something else to talk about with blobs, page blobs. These look like they're each 1 terabyte in size, but they're actually not underneath the hood. What Windows Azure Storage Blobs implements is sparse storage. So what's actually stored there is just what you've written to those disks. I've just formatted those disks and partitioned them. So each one probably is only taking up tens of megabytes of space, however big NTFS requires for a giant 1 terabyte volume. That's all I'm paying for. And as I write to it, I start to accumulate more storage underneath that. But basically what I've got is a virtual disk there of 1 terabyte. It's basically a dynamic, same thing as a dynamic VHD. And like I pointed out, because this is standard Storage Explorer tool, I can do things like download, copy, and all of the other operations that you can do with standard page blobs. Okay, let's, oh, and one more thing. The way that I created that 16 terabyte disk, so as part of the demo scripts, or as part of setting up for these kind of demos, we don't want to have to sit here and create all these virtual machines by hand in the portal. But what we do is create PowerShell scripts. Everything that we've done is REST API exposed, and also we've created PowerShell scripts for all of them. And so I'm going to show you this create Windows Server script, and here it is. So you can see instance size extra large. Here's the name. There's the image. The image is actually right here. So we picked Server 2012. And then you can see that piped into this PowerShell script are a bunch of commands to create a new disk of 1 terabyte, giving them each a label. You can even specify the LUN and then specify where in Windows Azure Storage you'd like those VHDs to be placed for those new VMs. So PowerShell scripting for everything that I'm showing you in this presentation. All right, now we can switch back to the PowerPoint. Now, I want to clarify something that you might run into when you're using the portal, and that's to explain the difference between a virtual machine and a cloud service. If you listen to our marketing messages, we kind of position cloud service as the platform as a service way to group things, and virtual machines are the infrastructure as a service. When in fact, cloud service really is just a container, and when you create a standalone virtual machine, I'll explain what happens with respect to cloud services. Here, let's switch back to the demo machine because I'm going to go ahead and spin up a new VM to demonstrate what I'm talking about in the next few slides. This 16 terabyte virtual machine, you'll notice that it's part of a URL, TechEd 2012 IaaS cloudapp.net. If I go to Cloud Services, I don't see TechEd 2012 IaaS. And that's because I created that as a standalone virtual machine. What I'm going to do is create another virtual machine. And this one, I'll go ahead and create a Linux machine. Demo. Let's give it a standard user account. See if I can match the passwords this time, and it looks like I did. Press next, and now I get asked that question, do I want to create it standalone or add to an existing one? At this point, I'm going to add it to that 16 terabyte VM. So that's going to take a few minutes to create. In the meantime, let me explain what's going to happen underneath the hood. Let's go back to the slides. When you create a cloud service using Visual Studio with web and worker roles, you get a configuration like this. We've got a web role. It's got a number of VMs, instances underneath it that are PaaS instances. We've got a worker role. It's got a number of VMs that are PaaS instances as well. And wrapped around them is a cloud service. So the roles and instances. Now, when you create a standalone VM, like that 16 terabyte VM that you saw in the portal, you see standalone VM, you don't see cloud service, but there's an implicit cloud service that isn't exposed to you. Just because we wanted to make it really easy for somebody to come to the portal that doesn't know anything about cloud services and be able to create a virtual machine without having to be confronted with, okay, now there's a virtual machine and now there's a cloud service. But there is an implicit one underneath the covers. When you add a second VM, like I just did with that Linux VM that I created, and connected it to that existing VM, now the cloud service is going to surface for you because that's the grouping concept we've got. So before we flip back, let me see if it's showed up. Yeah, let's flip back to the demo machine. Already, and I think this Linux VM is still being provisioned. You see this initializing, but you can see that now in cloud service, that TechEd 2012 IaaS showed up. That was the DNS name for that standalone virtual machine, which doubles as the cloud service name, because cloud service names map directly to the DNS name that you get in Windows Azure by default. Of course, you can bring your own DNS name. But now that was the virtual machine that I used as the baseline that I added the other virtual machine to, so that's the default cloud app name for this new cloud service, or this cloud service that now just made its appearance. And this virtual machine is still starting up. So we'll come back to that in a minute, and I'll explain, or I'll demonstrate what cloud services gets you. Let's go back to the slides. This grouping, besides being something that makes it possible to manage multiple VMs at the same time, so I can delete them at the same time, I get a bill that shows me what's going on with that cloud service, it also is a virtual network boundary. So those virtual machines can see each other, and by default, cloud services can't see each other, other than through the public IP addresses that they're given. When you put the VMs together, wrap them in a cloud service, now they're on a virtual private network, so they can see each other without having to go through their public IP addresses. And let me see if this is ready for us to show a quick demo of that in action. Yeah, nope, still booting up. The Linux machine is booting. It'll be ready in a few seconds. What we're going to do when this is ready, and I might just wait until we get to the virtual networking part to show this concept at play, is that I'll be able to ping the Windows machine from the Linux machine because they're part of the same cloud service using the internal IP address, whereas somebody else in a different a different cloud service, another virtual machine, can't see those those internal IP addresses because they're blocked by the virtual networking firewalls that we create in the infrastructure. Okay, let's go back to the slides. Oh, we are on the slides. So that's the demo I just walked through. And like I said, I'll come back and show you that ping in a second. Let's talk about virtual machine availability now. So when it comes to our SLAs, if you go read our public SLA document, it says that we offer 99.95% connectivity SLA to your front ends of your cloud service. And what that means is that a cloud service, to get that SLA, needs to have at least 2 instances in it. So for example, 2 web roles sitting behind port 80, behind the load balancer, we're guaranteeing that 99.95% of the time, you'll be able to hit one of those 2 instances. What that does is make a contract with you about our planned and unplanned outages. First of all, the unplanned outages happen for obvious reasons: disks going bad, memory going bad, network NICs going bad, all sorts of hardware failures that can take place when you've got a data center. It also makes a contract with you for our planned outages. We're running Windows Server, Hyper-V, underneath our fabric, and that means that we need to patch it to be secure. We also patch it to fix reliability issues and improve performance. And so we do this patching. You can guess about how often we do it. It's about as often as you're doing it, which should be once a month. You can guess about what time of the month we're doing it. And when that happens, we roll through the data centers and we honor our SLA using a concept called update domains. And we honor the contract with you about faults or failures of hardware using something called fault domains. So where am I going with this? Well, with single multi-instance PaaS applications, we offer this 99.95. We wanted to offer something for single instance machines too. If you take the 99.95 and you say, what does that imply about a single instance? It's 99.76. Now, that's not a very round number. It's actually not a number that people really like. People, when they talk about SLAs, like to talk about number of 9s. And so we decided to go with a number of 9s and say that our single instance SLA is going to be 99.9%. We're in preview right now, so we don't really offer an SLA on our single instances. When we go to general availability, this is what you should expect. Whoops, flip this upside down. There we go. So 99.9%. That's about 8.5 hours of downtime a year. So that's downtime, more downtime than some people would like for their more important applications. So that's where something called availability sets come in, which lets you take multiple virtual machines and wrap this concept of fault domains and update domains on top of them. Now, what's a fault domain and what's an update domain? And that, by the way, that lets you get the same 99.95% availability that you get for our PaaS services. But what's a fault domain and what's an update domain? A fault domain represents single points of failure in the data center, and an update domain tells us, A, if you've got a PaaS service, how we roll updates that you give us out to those instances that are part of a role, and B, what order we service the servers in the data center so that we can guarantee that we don't take down VMs from more than one update domain of your role at a time. So let's take a deeper look at this update domain and fault domain concept by taking a look at how they map onto a cloud service, a PaaS cloud service. You can see here I've got a web role. It's got 4 instances. I've got a worker role that's got 4 instances. And by default, you get 2 fault domains for any role. So we'll spread these 4 instances across at least 2 single points of failure in the data center. And you also get a number of update domains. By default, you get 5 update domains. You can ask for up to 20. And this means that we'll never take down for a planned outage, whether it's us servicing the server underneath or you deploying an update to this, more than that number of update domain, more than that number of machines, number of instances divided by number of update domains at a time. So in this case, let's say that we've got racks. We'll deploy this thing to 2 different racks to spread it across at least 2 fault domains. We always try to spread across more than 2, but that's our guarantee. So rack is a fault domain because there's a top of rack router on the top that's not redundant. So if that thing fails, then we lose connectivity to the whole rack. And then we also map update domains to match the fault domains. And so you can see that we've got 2 fault update domains here. We could have had more if we wanted to, but 2 update domains means that when we roll a host OS update out through the data center, that we will take down update domain 1, reboot it, make sure that it comes up healthy, and then move on and service the servers under update domain 2. Same thing when you apply an update to the web role. It'll apply to update domain 1. Once that update domain's healthy, then we'll move on to update domain 2. So availability sets lets you take that update domain, fault domain concept and apply it to arbitrary virtual machines. A virtual machine underneath the hood really is a single instance role. So this is taking those role concepts that we had for PaaS, lifting them off, and letting you basically create IaaS roles out of multiple virtual machines. So here, I wrap these 2 tiers into an availability set. I've basically created the equivalent of the web and worker role from an availability, from a fault domain, update domain perspective. And so that means that we'll spread them across at least 2 fault domains. And we'll put them in different update domains. So now when we service the host OS, you'll see that we'll only take down 1 of these at a time. So this allows you to get high availability, the 99.95% SLA, and when we're servicing the host OS, 100% availability through that kind of operation for a tier that you've deployed in this manner. Let's go to, oh, here we go. So let's go back to the demo machine, and I'm going to show you how this app that I've got here, this cloud service right here, Fabricam Cloud Apps, if we take a look underneath the hood of it, it consists of 4 VMs, just like I had in the slide. These 2 front-end, Web App Manager 1 and Web App Manager 2, 2 back-ends, the SQL 1 and SQL 2. And if I click on the front end and go to Configure, you can see that I put these front ends in availability set. So again, I get that 99.95% SLA for the front ends from fault domain and update domain perspective. Okay, let's go back to the slides. Let's talk a little bit about Windows Azure Virtual Networking. So we added a whole bunch of networking features with this release. One of them is that you get full control over the VM names. You notice that I assigned the virtual machine a name, and that means it's assigned to the computer, but more importantly, it gets published inside of the internal DNS of the cloud service. And I'll explain that more in a second. Actually, right now. So when you have a PaaS service, when you had one before this release, and your web role, for example, wanted to find the IP address of the worker role instances, they had to use a PaaS runtime API to say, give me the IP address for web role instance 1. Now, most server applications, they use DNS to look each other up. So we didn't have DNS services inside of a cloud service before, so we needed to add that so that server applications could look up their VMs using DNS names. So the IAS front end can look up the SQL server using the SQL server's machine name and not call some PaaS runtime API. So Windows Azure provided DNS, gives you DNS within the cloud service boundary. So I mentioned before that the cloud service is kind of like a virtual network boundary. Private IP addresses are all visible within it, and the DNS names are all visible within it. And let me see my Linux instance. Yeah, let's switch back to the demo machine because I'll demonstrate that ping and the DNS name resolution for this Linux demo machine. So first thing I needed to get is the SSL connection, or sorry, the SSH connection information here and use this little putty tool, which lets me here's the host name and the port. Whoops, didn't do a copy. Control C, Control V. And administrator. And now we can ping the 16 terabyte machine, which has a name right there. And it looks like it's not working. Why is it not working? Because of the firewall, right. Now, one of the things that we do for PaaS is you've got to explicitly go and open ports on a role to make them visible even internally to the cloud service. What we've done with virtual machine roles is they're wide open internally. So anybody can ping any port, basically dynamic port support for virtual machines, but you still got to go change the firewall inside the virtual machine to allow connectivity from the outside. So let's go Control C, and I'm still RDP'd in here. And what I'm going to do is open up the ICMP, and then let's go see how quickly that works. And there we go. So that's using DNS name resolution within this cloud service, and you can see that's the private IP address that we're pinging because they're both part of the same cloud service. This won't work across cloud services for obvious security reasons. Let's switch back to the slides. Now, we've got this DNS service that goes with, by default, cloud service, but that doesn't stop you from bringing your own DNS services. In fact, you can deploy your own DNS server within a cloud server. You can point at a public DNS service, or you can use the gateway and then point at a DNS server that's back on premise as well. Okay. Now, there's a number of other features that we added. So for one is lots of server applications use UDP and not TCP. So we enabled UDP support in Windows Azure. And like I mentioned, we dynamic ports for ICMP, UDP, and TCP on virtual machines, so you don't have to go and configure something in the service model and open up ports on the roll. They're just open automatically, and all you have to do is worry about the firewall inside the virtual machine to be consistent with the way you manage virtual machines on premises. We also got something called port-forwarded endpoints and custom load balancer health probes we introduced with this release as well. Let's talk a little bit about those. So by default, well, actually not by default, just a fact of life, every cloud service in Windows Azure gets a single public IP address. This is what we call the VIP, or virtual IP address. This is a publicly routable on the internet. That's what's bound to the cloudapp.net DNS name that we give you, and that you can bring in your own CNAME and slap onto it. Because there's only one IP address for a cloud service, and you can have multiple virtual machines in a cloud service, we ran into a problem with virtual machines. And that is, how do you access a specific virtual machine? In PaaS, that wasn't so much of an issue. The only time you really needed to access a particular virtual machine in PaaS was to RDP into it for troubleshooting. And the way we handled that is we put an RDP forwarder agent inside of all of the virtual machines in your roles when you enabled RDP, so that when you went in through the front end, through the load balancer and hit one of the front ends, then that front end would route you to the right virtual machine internally inside the cloud service and proxy the RDP traffic. For virtual machines, we couldn't do that. We can't get an agent in there, for example. You don't need an agent in these virtual machines. And then we also didn't want to have this this routing going on. So we needed a way for you to actually hit a particular virtual machine, even for cases just like RDPing in, like I did to that virtual machine a little bit earlier. So for that, we introduced something called port forwarding. What port forwarding does is takes a virtual machine, what it sees as a published port number, and then maps that into the public IP's addresses port range in the dynamic port range space. So basically, what you do is, if there's two virtual machines you want to RDP into, they both open up port 3389, but on the public IP address, they each have different ports. And when you use the portal to download the RDP file, it's already pre-configured with the IP address, with the DNS name, and the right port number to hit that RDP server. Let's go back to the demo machine, and I'll show you how you can see that port forwarding mapping. Again, the Web Apps Manager, the front end's here. When I go to endpoints, you can see that I've got a web endpoint, and it's behind a load balancer here. But I also have an RDP endpoint. We don't want that to be behind a load balancer. We want to be able to hit that directly. And so you can see here that the private port, standard 3389, so you just open that up in the firewall in the local VM the same way you always do. But when you come in through the front, through the public IP address, you're going to hit the DNS name, port 55182, to hit Web Apps Manager 1. For Web Apps Manager 2, the port mapping is this. 62.214 on the front end maps to 3389 on that particular virtual machine. So that's the way we enable you kind of specific addressing to virtual machines through the single public IP address. Let's go back to the slides. Another aspect of the roles that we have in Platform as a Service is automatic configuration of the load balancer. When you create an input endpoint, which is an endpoint that is mapped onto the public IP address of the cloud service, it's automatically load balanced. So when you create a web role with port 80 as the input endpoint, and you create multiple instances of the web role, it's behind the Windows Azure load balancer, and traffic will get sprayed across those front ends. Again, this is a concept that came built into what we call a role. And virtual machines are single instance roles. So we needed to lift that concept off the role and make it so that you could apply that to whatever arbitrary collection of virtual machines you want to be behind a load balancer. We call this load balance sets. And when you create a load balance set, you specify the public port, the local port that you want that public port to map to, which protocol, whether it's TCP or UDP, and you give it a name. And then what happens is all the virtual machines you put in that load balance set now are behind that load balancer, and requests coming in to that public port get sprayed across to that private port on those instances. You saw me demonstrate, and actually another aspect that a feature we also introduced is custom probes. So with our Platform as a Service, the guest agent sitting inside the web role would respond to probes from the load balancer for health. Every 15 seconds, the load balancer says, "Are you healthy?" The agent would return HTTP 200 and say yes. And only if it missed a couple probes would the load balancer stop directing traffic to that instance. With load balance sets, generally as a feature of our load balancing now, we introduce something called custom probes, which lets you specify a URL that you want to hit, a relative URL that will get probed by the load balancer, because we don't have an agent running in your virtual machine, so you need to tell us what URL you would like the load balancer to go ask for health. So you create, for example, IS front end. You create a little sub-URL that you're responding to with HTTP 200s, like health status. You configure that now, and the load balancer will go probe that address for health statuses. We've also got something else coming out. It wasn't released a couple weeks ago, but it'll be released soon, and that is a custom timeout for the probes, a custom probe interval, and a custom number of timeouts for unhealthiness. So by default, it's 15 seconds. You miss 2 probes, you're unhealthy. You'll be able to set it down to, say, 5 seconds and say that you want to miss 2 of those to be unhealthy for a total of 10 seconds before the load balancer takes your instance out of rotation. So you'll get much more control over the load balancer soon. Let's go back to the demo machine, and I'll show you just quickly how we've configured this Web Apps Manager for load balancing. Again, when I go to endpoints, I showed you this in the keynote as well. We've got the web role, we've got a endpoint with a name called web, public ports port 80, private ports port 80, and it's behind the load balancer. And looks like the demo script failed to add that to the load balancer. But this should, the other web role should be sitting here as part of that load balance set. And actually, I could go and say, I want to add that to the load balanced set by adding, wait, it says, oh, I clicked on the wrong one, sorry. There we go. Not a demo failure, of course it's not. There's no bugs. So here we go. You can see the two front ends sitting here behind the load balancer. Okay, we can go back to the slides. So let's talk about connectivity, IP level connectivity when it comes to on-premises in the public cloud. About a year and a half ago, we introduced something called Sydney. It's also called Windows Azure Connect. And what this allowed you to do was stick an agent in your PaaS roles and then stick an agent in a machine on-premise, and those two agents would create a private IPsec tunnel between them. And used through that tunnel, if you had things configured properly, you could basically extend your intranet up into Windows Azure and have those Windows Azure machines even domain join a domain that's sitting here on-premise through that Windows Azure Connect agent. Now, the problem with that kind of scenario is that if you wanted that domain join, for example, you needed to put the agents right there on your domain controller. And for some reason, IT pros are a little skittish about putting stuff on their domain controllers. It's great, though, as a dev test kind of thing, where I want to be able to have a private tunnel up into my cloud service and then deploy stuff into. But we needed something more robust, something that IT pros know how to manage and control when it comes to bringing some other set of machines from an outside network and making them appear as part of the local network. So with this release, we introduced Windows Azure Virtual Networking Gateway. And the gateway is a VPN gateway solution that lets you connect your on-premises to your cloud. Now, there's two ways that virtual networking is used. The overall name is called Windows Azure Virtual Network, and gateway is one feature of it. Windows Azure Virtual Network essentially lets you create a network overlay of IP addresses and put them on top of a cloud service. So I could go say this cloud service is part of this subnet. They'll all get IP addresses assigned from that subnet range. And then with gateway, I can connect them through a VPN gateway device, like a Cisco or Juniper device, to my on-premise network. If I've configured the subnets properly, they can fit into my private IP address space on-premise with their own carved-out subnets ranges up in the cloud. And then everybody can see each other using IP addresses. And if I configure DNS, then they can also see each other's names as well. So my on-premise machine can go talk to my machine up in the cloud using its DNS name, using its machine name, because it's registered with the DNS server, whether the DNS server is in the cloud, typically on-premise. So the reason that you'd want to, for example, create a virtual network that's not even joined to on-premise is to connect two cloud services together, because you can overlay these virtual networks not just on one cloud service, but across cloud services. So if I want to have cloud service A talk to cloud service B, but not have to go through the public IP address, like, for example, I want to have cloud service A talk to a SQL server in cloud server B, but I don't want that SQL server sitting on the internet. I can basically not have any input endpoints on cloud service B. Cloud service A can hit the SQL server machine directly using an IP address, and if they're configured with some DNS server, through its DNS name. In the second scenario, there's one caveat to that, is that in this release, we don't have the Windows Azure provided DNS to span cloud services. So you saw me earlier use a DNS name resolution to ping two machines inside the same cloud service. If I just put a virtual network on top of that cloud service and another one, that ping wouldn't have worked using the DNS name, because the DNS doesn't span two cloud services. They're private to each cloud service. That will come in the future, but in this release, that's one of the limitations of this VNet configuration. This app that I've got right here that I've been showing you is actually connected and domain joined to an on-premise domain using the gateway feature, which I also showed you this morning in the SharePoint demo. And in this case, we've taken the VNet, we've created subnets for the different collections of machines, the front ends, SQL Server back ends, and I've also put a domain controller up there in the cloud, which is part of the domain on-premise, connected through to on-premise. So now and there also acts as a DNS server. So I've got a DNS server sitting in the cloud on the domain controller, also the Active Directory domain controller on-premise, which is also a DNS server. That means if either of those fail, DNS name resolution will still work because the cloud will use whichever one happens to be functioning. The virtual private network there connects that VNet up in the cloud, integrates into the IP namespace of my on-premises network. Let's go take a look at that. So switch to demo. So the virtual machines I've been talking about here, Web Apps Manager 1, Web Apps Manager 2, SQL 1, SQL 2, and here's my Cloud DC. And when I go to Web Apps Manager 1, if you go to Endpoints, or you go to Configure, you can see that I've mapped the front ends into this front end subnet, which is 10.3.1.0/24 IP space. You can see that I've got Web Apps Manager 2 also mapped there. SQL 1, by the way, these SQL servers are mirrored, so that's why you see that SQL witness. And you can see the back end, 10.3.3.0/24. And then we've got the Cloud DC here as well. And these are all part of this virtual network here at VNet, on-premise, in the cloud, those three subnets that you saw being referenced. And we've got two DNS servers, like I mentioned, the Cloud Active Directory and the Corp on-premise Active Directory domain controller. If I go to Configure, I can see the IP addresses of those DNS servers. And what I'm going to do is I'm going to RDP into the Cloud Active Directory, show you that all those machines are domain joined to that domain, and then from there, using this private IP address, RDP into my on-premise domain controller. And I'll also show you the Cisco configuration that we've got sitting there, the Cisco management tool on that domain controller that has configured this gateway. So let's go back here, and I'm going to RDP here. And I've actually already placed that in there. If you just take a quick look back, you can see that I'm not cheating here. Here's 192.168.1.6, 192.168.1.6, and now this actually domain controller is sitting under somebody's desk back on Microsoft's campus. So I hope they don't kick it while we're doing the demo. But what I'll do here is show you that I've got Active Directory users and computers. And you can see that these two VMs here, Azure VMs, Web Apps Manager 1, Web Apps Manager 2, sitting there, domain joined up in the cloud, and we've got the other one sitting over here in the computer's OU. So we've actually split those into different OUs even, which gives us different control over those. This, obviously, is the Cisco management console, and here's where I've configured the gateway to connect up into Windows Azure. No applause? No, just kidding. I thought I heard one. That just got me excited, but I guess not. All right, so let's get back to the slides. So this last few minutes we've got, I want to take a step back and talk about what we've shown infrastructure as a service in the larger context of what I talked about at the beginning of the presentation, which is as an on-ramp to Windows Azure, for you to be able to bring existing applications up into Windows Azure. And the fact of the matter is that some people will take their existing apps, toss them up into the cloud. They might be a line of business app that's been working great for a number of years. You might not even have the source code to it anymore, just chugs along, but you want to get it, take the efficiency of the cloud, so you toss it up, and it sits there and lives out its life peacefully as an infrastructure as a service app. We want to make a great platform for those kinds of apps. But we also wanted to make sure that if you've got an app that you really care about, it's a more complex app. Maybe it started out on-premise and you're putting it up in the cloud, like that SharePoint farm we saw this morning, or it's a brand new app that you're creating up in the cloud, and you need to put in server applications into those VMs for which there are no comparable or compatible cloud services. For example, SQL Azure might be missing features that you take advantage of in your application SQL Server deployment. So SQL Azure might not be an option for you today. So you'll deploy your application, put SQL Server into a virtual machine, maybe hopefully mirror it, and eventually you'll have failover clustering with it as well. And at some point, SQL Azure gets more feature-rich, and at that point satisfies the needs of that application, and then you could take and migrate that. So this next few slides, I'm going to show you how we take that same exact application, this Events Manager app that we've been looking at, and migrate it from being pure infrastructure as a service, where you saw that we've got 2 IaaS front ends, 2 SQL Mirror on the back end, and start to move that into the world of PaaS, where we get the benefits of, you can see, PaaS is faster, PaaS is cheaper, PaaS is lower risk, blah, 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 marketing stuff. Let's just move on. So here's IaaS and PaaS side by side. Now, when it comes to migrating an application like that, so you might have part of it that you migrate to PaaS, part of it you leave in IaaS. How do you connect those 2 parts together? And there's different options for you depending on what you want to do. There's connecting them via the virtual IP addresses, connecting them via a virtual network like we've seen, and then something we call mixed mode. And I'll explain what mixed mode is when we get to that section. But first is, let's say that I take that Fabricam IaaS app, and I want to migrate the front ends to web roles, because that's probably the easiest thing to do, is just put those in a web role. Leave the back ends in SQL Server for now until SQL Azure is ready. But now I've got web roles on the front end, SQL Server on the back end. How do I connect those 2 together? Like I said, one way is through the virtual IP addresses here. So the benefits of putting them in different cloud deployments and then having the front ends talk to the SQL Server through a VIP is that it's pretty simple to set this up. I get the benefit of autonomy if I want it, so I can manage the life cycle of each of those independently. I can even have a SQL Server database that's shared across different cloud service apps. Maybe it's the customer database. I can do VIP swap. Now, this is a powerful feature of PaaS where I can deploy a new version, take the public IP address, and then flip it over to the new version in a one-step operation to basically take the old version offline and make the new version production. I can do that with the front ends. I can do VIP swap. Now, of course, VIP swap doesn't make any sense for a persistent VM role, because I would have to deploy a new version, make sure the state is exactly the same in both of them, and then do the swap so I don't lose any data in the middle. For SQL Server, that would mean that I'd be having to somehow basically do the swap at a point when the new SQL Server that I want deployed has the exact same database contents as the existing one, which if it's being hit with traffic, I'm never going to have that kind of point. So VIP swap really only makes sense for PaaS. I get easy local dev test, because the web roles I can go and deploy and mess with in Visual Studio, and the persistent service is easily accessible through that VIP front end. Now, the downsides of this are I pay a latency cost. Now, what's the latency cost of going through the load balancer? Because when I go through the front ends versus the internal IP addresses, I'm going through the load balancer. It's about 0.5 millisecond on each side. So a little bit of overhead there with the load balancer, so a little higher latency. It's less secure because now my SQL Server is sitting there on the open internet. Somebody can go and try to hit it directly, crack its password. And there's also management and deployment overhead of having to manage 2 cloud services. Another option is to connect them with VNet. So here I create a VNet. Doesn't even have to be connected through a gateway back to on-premise. I put these cloud services in 2 subnets, and now they can talk to each other using IP addresses. This is more secure, obviously lower latency because I'm going through private IP addresses. I get the autonomy still that I had before of managing the cloud service and the back end. I can still do VIP swap. And I've got advanced connectivity requirements maybe to satisfy as well. The downsides, though, is, well, VNet is advanced connectivity requirements, which requires you to be a little bit of a network admin to know how to set up subnets properly. And there's no, today, there's no DNS across these. So you got to bring your own DNS server, or you have everybody look each other up using just their static IP addresses that you get assigned from the subnets. So that's the downside to that for now. And this is that app, VNet joined. So this app, what we're going to do is take it and make the front ends into web roles, still talking to the same SQL Server database cloud service that we've got up there in the cloud, still talking to the same Active Directory machine, which is its own cloud service, all joined by VNet back to on-premise. So let's go take a look at how we can migrate the front end into being PaaS. And because this is a scenario that's really important to us, we wanted to make it really easy for you to do this. This is the front end to that Fabricam site. Actually, let me go hit the front end of the site so you can see what it looks like. Oh, yeah, I assumed they were going to. Sorry about that. So you didn't see what I was just doing, huh? What was I doing? I was showing you Web Apps Manager, virtual machines. I want to show you what this looks like. And we're going to migrate this to being from hosted in IaaS as part of infrastructure as a service to being part of PaaS. So there's the site. Go to Visual Studio. Here's that web app, events.web. How hard is it to make this into a cloud service web role? Done. There it is. There's the web role, events.web. So we've added tooling to Visual Studio so that it can take an ASP.NET website. We'll automatically import that and wrap it in a cloud service project. Now, if I did a build, set up the configuration, did a publish, I've got my PaaS front ends for that application. Now, the only thing I need to do actually is to VNet join it, which I can do by setting the cloud service configuration here. Now, to VNet join it, I've got a little XML snippet to show you what that would look like, because this will match what we've got up in the cloud. And there's how we, in the service model, would join this PaaS role to that at VNet that you saw. This is the event role name events.web, and we want to map it to that front-end subnet. So in just a few clicks, a little bit of typing in that service model, we've now got our front end migrated to PaaS, talking to SQL Server on the back end, which we already had configured here in this connection string to the SQL Server database. Let's switch back to the demo machine. Oh, sorry, the slide machine. And the final thing I want to mention is something that we don't have today, but we're working on it and should have this soon, and that is the ability for you to mix IaaS and PaaS inside the same cloud service. What we just saw was PaaS in a separate cloud service talking to SQL Server IaaS in a separate cloud service. How about if you could put those together, and now you get the benefits of a single cloud service? So what you would get is Windows Azure provided DNS, you get low latency connectivity between all the machines, and you get a single unit of management and lifecycle and operations. The downsides to this, well, you don't get VIP swap. Why wouldn't you get VIP swap? Well, because, again, you got that SQL Server problem that I mentioned. I say that it's coming in the future. How are we going to bring this in the future? Give you a little insight into where we're going with some networking. You will be able to assign, to be able to basically lease IP addresses and then assign them to cloud services, including assigning more than one to a cloud service. So what I could do with a VIP swap in mixed mode, still get my VIP swap for the front ends, is deploy a new role into the cloud service, call it web role new. I take an IP address that I've leased and assign it to that web role new. And that's my staging IP address now. And so I go bang on it, make sure it's working great, production traffic still flowing through the IP address that was already assigned. And now when I'm ready, say swap those, and now my old front end becomes my new front end and vice versa, or something like that. And their SQL servers are left alone because those front ends are talking to them using the internal DNS services of the cloud service. And so that's the full migration into mixed mode. And then the final step, of course, is once you're ready, going pure PaaS. And this would be taking that application, getting rid of the SQL Server dependency, and then having it talk to SQL Azure. And if we go back to the demo machine, I want to show that very quickly. Because making that change for this thing to use SQL Azure versus SQL Server. Oh, and by the way, just to show you, I've got all of these actually running. So this is the one that is a web role. If I go here, it's got a web role. I actually only deployed one from Visual Studio. But when I hit this thing, it's going to look exactly like what I had before. Except this is running in a web role, not IIS, like this one. And there we go. And so it's got the PaaS assigned default machine name here versus this one where we gave it a machine name. And then the final step, having it be pure PaaS, fixing the connection string here in web config. So let me get rid of the existing one. And I've already got a SQL Azure database connection string for a database that I created. And so here I go. And this is SQL Azure database connection string right here. And I publish that. And now, which I already have, and here's the full PaaS one. And if we hit that one, the difference will be the connection string. But otherwise, it looks exactly the same. So this one, notice the connection string down here, data source, failover partner, password, that's the SQL Server connection string. And here we go. There's that SQL Azure connection string. Otherwise, the functionality is exactly the same. So you saw me take this thing from being pure IaaS to being partial IaaS to being pure PaaS. And that's the kind of way that we'd like to make that transition, that evolution of applications that start in the standard server model and then migrate to the new modern kind of PaaS where you get the nice scalability, scale out and availability that you get with PaaS. So with that, I want to wrap it up. I go back to the slides here. I want you to think back on what I've shown you. And remember, we started with this slide here, which these are the goals that we set out for in this release. You can see everything from IT Pro experience, PowerShell scripting, advanced connectivity, support for key server applications, SQL Server, IS, SharePoint, Active Directory, high availability features with availability sets, load balance sets, port forwarding, VNet gateways. And again, I think a key differentiator for us is that we don't view these things as two different isolated worlds, but actually as points on a continuum. And the line between IaaS and PaaS really starts to blur fast, especially when you start to call on PaaS services from within a server, a persistent server VM. You're going to see us push that boundary really hard to make it possible to bring lots of PaaS functionality into IaaS and to make it possible for you to integrate IaaS and PaaS across VMs. Again, this is just the start of our journey down this path. Not even the GA release. You can see that we're already pretty feature set, and we actually made a deliberate effort to say what are the kinds of scenarios we want to unlock and what are all the features we need to unlock them. And so we got to this point, I think, where you can see that we have a pretty good story to tell that's only going to get better. So with that, I want to thank you very much. I hope that you find this functionality interesting and gives you a way to realize how you might start to take advantage of Windows Azure, even if you've got stuff that's not ready for PaaS. And want to mention that I'm speaking again 3 sessions later this week. On Thursday, I'm doing a Windows Azure internal session where I'm going to take you behind the scenes of our data center and the way that the fabric operates. I'll also be giving some tips about how to take advantage of that information to get more out of Windows Azure. That afternoon, I'm doing a session on malware cleaning with the sysinternals tools. And then finally, Friday, I'm closing, basically it's the last Friday afternoon, doing my Case of the Unexplained, fun Windows troubleshooting. So I hope to see you at one of those sessions. I hope you have a great TechEd. Hope you enjoy Amsterdam. And I hope to see you again later this week. Thanks very much.